Hey everyone, thank you for joining me in this video. In this video we will tackle the 8 queens problem. It's a classic puzzle where we have an 8 to 8 chessboard and 8 queens, and our goal is to place all 8 queens on the board so that no queen can attack another queen. So how does a queen move? A queen can move horizontally, it can move vertically, and it can move diagonally, this diagonal or this diagonal. Let's look at an example. In this chessboard, we played 8 queens, and no queen can attack another queen. For example, if we look at this one, horizontally there is no queen, vertically there is no queen, and then no diagonal there is another queen. And if you will check all the other queens on the board, you'll see they all meet those constraints. So here in this video, we would want to generate a random 8 to 8 chessboard that generates us this queen positions in such a way that they cannot attack each other. So we have a class, a queen 8 to 8, and we want to randomize a board. And now we're gonna apply our constraints on this board. So first of all, note that we will consider a queen as the number 1 and an empty cell as 0. And we will use this to help us write the constraints. We need to meet 4 constraints. The first one is that each cell is either empty or has a queen. Therefore, it's 0 or 1. The second constraint is that we have only one queen in each row. Similarly, the third constraint is that we have exactly one queen in each column. And the last constraint is that we have no 2 queens on the same diagonal. Let's see how it looks. The first constraint, pretty straightforward. We will call it the binary constraint. For each cell in our board, it could be either 0 or 1. The second constraint, we'll call it rows. And for each row, the sum of the cells in that row will be exactly 1. That's how we can make sure there is exactly one queen in each row. Similarly for columns, the column constraint, for each column on the board, the sum will be exactly 1. That's, again, what we need to make sure when we want exactly one queen in each of the columns. The last constraint is a little bit tricky, and we will now dive a little bit into it and try to find a logic that will help us to write a constraint that meets this requirement. Let's look on our chessboard. It's an 8 to 8 chessboard, and let's give numbers to our rows and to our columns. We'll try to use those numbers and find some logic that will help us to specify which column we're checking. So let's start with those columns, the one that goes this way. If we calculate row minus column, we get the following results. As you can see, each diagonal has exactly one number, has a unique number. We can use this to our advantage when writing the constraint. Similarly, when we check those diagonals, and we calculate the addition between the row and the column, we also get a unique number for each of those diagonals. Okay, let's use it to our advantage. Okay, let's look at the diagonal constraint. We will check every 2 cells, and to make sure that we check each pair once, we will add this if statement and move on to those 2 if statements, which are the interesting one. So as we saw before, when we have the first cell, row minus column equals to row minus column, we know that cell 1 and cell 2 are on the same diagonal, which is this kind of diagonal. And similarly, when we look at R1 plus C1 equals R2 plus C2, now we know that we are on this diagonal. Okay, and let's look what we have written here. It's similar in both of them. We say that we have a not on the first cell, logic, and the second cell. What does it mean? Let's look at this truth table to try and understand. So the only case this thing will be valid is when one of the cells, when both of the cells are not 1 and 1. Because if they're 1 and 1, the solution of the end, the logical end, will be 1, and the not will make it 0. So it's not a valid solution for the solver. The solver would want to choose only the valid solutions. And the valid solutions we get only when cell 1 and cell 2 are 0, 0, 0, 1, or 1, 0. So that's the idea behind it. Now we will add a print method, which is pretty straightforward. We run over our 2-dimensional board, and we check when a cell equals 1. When it's 1, we will print a Q. When it's 0, we will print a dot, and that will just show us a relatively nice chessboard with queens. We will run this very simple test bench and generate few boards, and let's see the results. So if we run it, we can see, for example, those 2 boards. If you go over those queens, you'll see that none of them can attack another queen, and we met the requirements. So I hope this video was interesting and you learned something from it. Please comment and share if there are other videos you would want me to upload to this channel. And please support this channel by subscribing. Thank you again, and hope to see you soon.